So this is the equation, and they've given us, they said we should find the bulk modulus of elasticity of the liquid. The pressure of the liquid is increasing from 70 Newton per centimeter square to 130 Newton per centimeter square. So this is the change in pressure, which is dP. So that's how we calculated dP as 130 minus 70, all in Newton per centimeter square. Then they told us that the volume of the liquid was decreasing by 0.15%. That's the reason for this minus here, because it is decreasing. And if you are going to represent this in mathematical form, it's going to be 0.15 divided by 100 because of the percent. So when you use the formula, K is equals to dP over minus dV over V, you arrive at this. So when you get this, the answer will be 40,000, or you say 4 times 10 raised to power 1, 2, 3, 4. So 4 times 10 raised to power 4 Newton per centimeter. So this is the question we are given. An open tank contains water up to a depth of 2 meters, and above it there is an oil of specific gravity 0.9 for a depth of 1 meter as shown. So this is the this is both of the liquids, oil and water. Water is beneath, then oil on top. So oil has a specific gravity of 0.9. So they did not give us the density of oil, and we are going to be needing the density of oil and water. So we know the density of water as 1000 kilogram per meter cube. So if you want to calculate density, remember when we were doing fluid properties, we said density of the substance will be equals to specific gravity of that substance multiplied by 1000, which is the density of water. So if you got that formula from specific gravity, is equals to density of substance over density of water. So you just say that density of that substance now is equals to specific gravity of the substance multiplied by 1000. So that's how we get our oil. So when we use 0.9 that we're given in the equation multiplied by that 1000, we get the density of oil. So where are we going? It says we should find the pressure intensity at the interface. Where is the interface? The interface is the top of the liquid at the interface. And what is at the top here? It is oil. So we are dealing with oil. We take both height of the fluid as Z1 and Z2. Mind you, it was water that they mentioned first in the question, so we are taking water as Z1. So Z1 will be what? 2 meter, as you can see. Then Z2 will be what? 1 meter, which is the height. So after that, when you are calculating the pressure intensity, the formula that you are going to be using is rho GZ. So that rho GZ, what was it? It will be the density multiplied by gravity multiplied by the height. So for pressure intensity at the interface, the density of oil, remember we calculated for it the other time, is it here? Density of oil is equals to specific gravity of that oil that was given us in the equation, then multiplied by 1000 is a constant. So that's how we got this 900, then multiplied by, this is gravity, we all know that, then multiplied by the height, which is 1. You will get this as your answer, 8.829 Newton per meter square. You are calculating, we are giving you height in meter, that's why it's in meter square. But now you convert to Newton per centimeter cube. What do? Divide it by 10 raised to power 4 or 10,000. So you will get 0.8829. So now that's for the interface. The second question is that you should calculate the pressure intensity at the tank bottom. So what's the tank bottom? Now you are calculating pressure intensity from the bottom. Now it will include both oil and water, because intensity from the bottom will automatically capture the both of the fluids in the container. So now we are doing pressure intensity for oil on one side and for water on the other side. So what am I calculating? The pressure of the oil and water. Remember we calculated for oil, pressure intensity for oil here. So we use this, we brought it here, then we use the pressure for the water, which is P1. You know the water for water is 1000 kilogram per meter cube, then multiplied by the gravity and the height of of the water. Remember I said the height is 2 meters, so that was Z1. So when you calculate everything together, we're going to have 28,449 Newton per meter square. So we can convert it to Newton per centimeter square by dividing it by 10 to the power 4. So you're going to be having 2.8449 Newton per centimeter square. So that's the end of this video. Thank you very much. Like, subscribe and share, comment also.